So this is 2017 AMC 12B problem 13. In this figure below, 3 of the 6 discs are to be painted blue, 2 are to be painted red, and 1 is to be painted green. 2 paintings that can be obtained from one another by rotation or a reflection of the entire figure are considered the same. How many different paintings are possible? And we have a graph and we have 5 options A, B, C, D, E. So what would be our first thing to do? So our first thought would be casework, because we don't have any, we don't seem to have acquired any knowledge about how to do this type of problem. So let's just try casework. So 1, 2, 3, 4, 5, 6. Let's just label the position of these discs so that we can do casework easily. So let me just write this down, casework. Alright, so what do we do casework for? We can't just list out every single possible case. That's really time consuming. We have to choose a color or any position. So I decided that we should choose color blue. So we should casework for all the blue discs because there are 3 blue discs. So the blue disc, the ordering of the blue disc is actually our majority of our problem. Once we've resolved the ordering of the blue disc, we can easily count, or easier than the other casework types, we can easily count the number of red and green orderings. So let's start out with case 1. So I've labeled my positions I've labeled the circles with numbers so I can represent my positions on each of my discs easily. So the first combination, so let's have 1, 4, 6. So 1, 4, 6 basically means we have all of our discs of our blue discs at the corner. So 1, 4, 6. The ones I highlighted in blue are blue. So how much subcases do we have for the red and green discs to be organized for 2, 3, 5? So we can have red, red, green. That's one subcase. We have green, red. So we have green. We have green, red, red, and we can also have red, green, red. So basically we have red, red, green, green, red, red, and red, green, red. However, in this case, for example, if I have green here and I just rotate this graph to this direction, then I result in having, if you can imagine, then I result in having my green over here. So red, red, green is the same as green, red, red, because my graph can be obtained from one another by rotation or reflection of the entire figure. So these two are considered the same. So we eliminate one case. So let's just eliminate this case here. So we have 2 cases. So are there 2 subcases? Well, let's try this out. So if I have green, red, red, so the uncolored discs are red, and then if I just reflected this graph across this axis, then I end up with red, green, red. So these 2 cases are also the same. So we have to eliminate another one case. So finally, we actually only have 1 subcase, which is green, red, red, or you can rotate it and create all the other cases. So we have 1 case, or 1 subcase. So let's talk about case 2 for our positioning of the blue discs. So case 2, let's try to have one of our discs in the center, so not in the corner. So either 2, 3, or 5 contains one of our discs, and 2 of our discs are at the corner, 1, 4, or 6. Okay, so let's see. What if I had 1? So what if I had 1, 2, 4? So basically this means this entire side here is gonna be blue. So how much cases do we have for that? We have green, red, red. We have red, green, red, and we also have red, red, green. So basically here we have 3 cases. So let's just check if these cases are all unique. Because for the last one we have 3 cases to start with, but we eliminated them to 1 case. So we have green, red, red. So uncolor this are red again. So we have green, red, red. And if I just reflected this graph across this axis in the middle, so this axis here, then I get so basically I get red, green, red. Okay, so these 2 cases are the same, so I have to eliminate 1. So let's just eliminate the first one. So basically I want to see if these 2 cases are the same. So I have red, green, red. So I want to see if I can change that into red, red, green. Well, unfortunately no, because green is here, so the green is here in the other case. So no matter how hard we try to reflect or rotate, the green here is just not going to be in the corners. It's in the center. It's not going to be in the corners. Alright, so we have 2 cases, for 2 subcases. So our third case for blue can be, so why don't we let it be, so we basically still have 2 discs, 2 blue discs in the corners, and we have 1 in the center. So 2, 3, 5, and we have 2 discs in 1, 4, or 6. So what if we have 1, let's say 1, 3, 4. Alright, we haven't tried that out before. So let's just try this. So I have 1, 3, 4, so 1, 3, 4. So basically here combinations are red, red, green, red, green, red, and also green, red, red. So let's see if any of these cases are repetitive. So if I just put my green here, then however the other 2 greens are not in the corner, so no matter how hard I try to reflect or rotate, I can't get my green to move from here into one of these 3 points because they're just not in the same position. So okay, so I have at least 2 subcases. So let's just try out if these other 2 cases are gonna be, repetitive. So let's put green here and see what we can do to make this green, red, red. So the problem here is that I have my reds separate from each other in this case. And in this case here, my reds are adjacent. So no matter how hard I try to reflect or rotate, my reds can't change from being separate to adjacent. So I have 3 unique cases over here. So that's 3 unique cases for 1, 3, 4. Alright, so let's look at our 4th case for the blue. So how about this time, let's see, I try to have 2, so I have one blue in the corner, and I have 2 blues in 2, 3, or 5. So I have 1, 2, 5. So we haven't tried that out before, so that's a good thing. So we have 1, 2, 5. So for the combinations of red and greens, we can have green, red, 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 green, red. So green, red, 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 green, red, or we can have red, red, and green. So here, let's just try and see if these are repetitive. So if I put green here, the problem is, for this case, my green is in the center position, so in 2, 3, or 5. I can't let a green with position 4 to rotate or reflect by any number of times to reach 2, 3, or 5. So okay, we have at least 2 cases. So let's see if this case and the third case is the same. So in the third case, we have red. So we have red, red, green. However, in the third case, so in the second case, so in the first case, the reds are adjacent, right? They're in 3 or 6 are adjacent, they're next to each other. However, in the third case, we have green, red, red. So the reds are not adjacent. So no matter how much we reflect or rotate, the adjacent must stay adjacent and the separate must stay separate. So we have 3 separate cases here because we can't make one or another the same. So we have 3 separate cases once again. So for our fifth condition, our fifth case for the blues, let's see. So what if so last time I had one blue in the corners and 2 blues in the center. Let's just continue and see if there are any more situations following this requirement. So obviously we have 1, 2, and 3. So for this case here, we have 1, 2, 3. So for this case here, we can have, let's see, green, red, red, or we can have red, green, red, or we can have red, red, green. So we have 3 separate cases. We're tempted to write 3 again. So however, we have to still check whether any are repetitive. So if we just check this, we know that the first and third are repetitive because I have green here for the first case. If I just reflect that across this axis, I have green over here, which gives me red, red, green from green, red, red. So the first and third cases are repetitive. So I only have 2 cases in total. So now let's just try out the 5th case. So the 6th case, that's our last case. So for our 6th case, let's just try and have all three of our blues in the center. 2, 3, 5. Okay, so we have 2, 3, and 5. So for this, we can have red. So we have red, red, green, green, red, red, or red, green, red. But however, if we just rotate our graph, we'll get the same. So we'll get that the 3 cases are essentially just the same case. So we have 1 case here. So if I just added all of these cases up, then I have 1 plus 2 plus 3, which is 6, plus 3 plus 2 plus 1, which is 12. So that gives me my 12 cases. So my answer here is going to be D, or 12. Alright, so my answer is 12, and the key takeaway in this problem is that we should do casework, and also we do casework in a certain order. So bye.